Hello everybody. In this video we are going to go over 2019 free response question number 1. So let's have a look at this question together. So fish enter the lake at a rate. So when we read the problem, if it's paper-based, we should highlight the important information. So fish enter the lake at a rate by function e, given by this function. Fish leave the lake at a rate by function L of t. Both E and L are measured in fish per hour. The unit is very important. And t is measured in hours. Since midnight, t equals 0. So first question, how many fish enter the lake over the 5-hour period from t equals 0 to 5 a.m., t equals 5? So give your answer to a nearest whole number. So for part A, in order to find the total amount of fish from t equals 0 to equals 5, we just need to take the integral from 0 to 5 e of t dt. And then we plug in the function and use our graphing calculator. To get the final answer, which is about 153.4577. Because it's a whole number, we are going to keep our answer as 153. So the only thing I want to say here is when we're trying to evaluate this in the graphing calculator, make sure you can treat variable t as x. It's the same thing. Okay, and everybody should get used to keep your answers at least 4 decimals. So for part B, what's the average number? So average number of fish that leave the lake per hour. So as we know, the leave the lake per hour is given by another function. Over the 5-hour period from t equals 0 to equals 5. So for part B, basically they are trying to test you the average value. So let's recall the average value of any given function f of x is equal 1 over b minus a integration a to b fx dx. So this problem, average number of the fish leaves the lake per hour will be given by 1 over 5 minus 0, integration 0 to 5. The rate is given by 4 plus 2 to the 0.1 t squared. Same thing, we plug this into our graphing calculator. Keep in mind, you can treat t as x, the same thing. And you will get 6.0590, approximately equal to this. C, at what time is the greatest number of fish in the lake? And justify your answer. Don't forget to justify your answer. So let's have a look at C. So we are trying to find the greatest number of fish in the lake. So optimization problem, we are trying to maximize the total number of fish. So for some students, if you look at the answer key, the answer is given by e to the t minus l of t equals 0. Okay, it's a little bit confusing. Why this is right? Because we want to maximize the total number of the fish. So first, what's the total number of fish? Let me use t. So t equals 0 to t e minus the amount of fish leave the lake. So this will be 0 to t e minus our t dt. So basically this function t gives us the total amount of fish in the lake at any time t, and t is between 0 and 8. And as we know, how do we find the maximum of any given function? We just need to take the derivative. So derivative of t with respect to time t, is given by, how do we take a derivative of an integral? We just need to use the second FTC, fundamental theorem calculus. So t prime equals e to the t minus r of t. And we set this equal to 0. So we just need to solve e to the t equals r of t. Or it's up to you. You can do either way. Use your graphing calculator. Once again, you can treat t as x. So after we solve this, we get t equals 6.2036. And don't forget, you have to justify your answer here. It can be maximum or minimum. How do you make sure it's a maximum? There are two ways, generally speaking. We can do the sign chart, which is t equals 6.2036. We check a t prime on the left and t prime on the right. So t prime is given by e to the t minus r of t. So we plug any number in, and we can see t prime is positive here and negative here. That's the first way. Or you can make a table. This is our time t. This is the total amount of fish there. So t, because it's a closed interval from 0 to 8, so 0, 8, and our critical point. So when t equals 0 and t equals 8, we should plug in, keep in mind, t equals integration 0 to t e to the t dt. E to the t minus r of t dt. Okay, the only problem is if you plug 0 and 8 in, it's a lot of work here. So this method is much more difficult than the first way. So I'm going to use this one. Use the sign chart. So on the left is increasing, on the right is decreasing. So it's give us max at t equals 6.2036. So this is part C. Let's look at part D together. So is the rate of change in the number of fish in the lake increasing or decreasing? So basically what we learned before, how do you check given any functions increasing or decreasing? We need to find the derivative of that function at that point. So the rate of change in the number of fish will be given by the rate enter the lake minus the rate leave the lake. So this is our rate of change function. Okay, how we are going to see if it's increasing or decreasing? We just need to take the derivative. R prime equals E prime minus R prime at t. So let's have a look at t equals 5. R prime is positive or negative. So R prime at 5 equals E prime minus 5. You can use your calculator and plug everything in. This gives you approximately negative 10.7228, which is negative. The derivative is negative, so the rate of change in the number of fish is decreasing. Now part A, B, C, D are all done. Let's put everything together and let's have a look how they grade your test. Okay, this is the 9 points problem. So the first part, 2 points, 2 points, 3 points here, and 2 points here. So I look at the rubrics. So this is 1 point. Final answer, 153, 1 point. Integration, 1 point. Final answer, 1 point. Okay, next one. This derivative, you have to understand what's the rate of change. This is 1 point. T equals 0. T equals 6.2, 1 point. And the sign analysis. Explanation, 1 point. And the last one will be 2 points. One point here, and 1 point explanation.